Now let's talk about another type of transformation that we can do to the exponential functions and how it affects the graph. So let's go ahead and sketch an exponential function. Let's do 2 to the x. So we'll make a scaling, label some axes, and we'll sketch our graph. So 0, 1, 1, 2, 2, 4, -1, 1/2, and -2, 1/4. And let's go ahead and label some x and y values here. Go ahead and connect with a smooth curve as is typically done. There we go. And what we're going to do is we're going to investigate the graphs -2 to the x and 2 to the minus x. Now, 2 to the x, if you label that as f of x, then 2 to the minus x, that would be f of -x, and -2 to the x would be negative f of x. And this allows us to easily identify what type of reflection we have here. We see here the negative is on the outside. That's a reflection about the, well, in the vertical direction, which makes a reflection about the x-axis. And here the negative is on the inside, so that's about the y-axis. Let's reflect about the x-axis first. So we'll need some scaling on our negative y-axis here. So we can go ahead and plot these points. And remember, we're just taking the y value and we're multiplying it by -1. So we get a nice reflection about the y-axis here, or excuse me, the x-axis here. And then we can sketch the graph of f of minus x. Let's go ahead and label this. This one is -2 to the x, or in other words, negative f of x. And we can sketch f of minus x. We just simply multiply the x value by -1. So the y-intercept does not change. If we look all the way to the right at 2, 4, that would become -2, 4. Then 1, 2 would become -1, 2. -1, 1/2 would become +1, 1/2. And we'll fill in that last one there, which is +2, +1/4. And we get a graph of 2 to the minus x. 2 to the minus x, which is, in other words, f of -x. So let's talk about a few properties of reflecting this graph about the x-axis, some of the results of the graph here. And these results are going to be true no matter what the base is. So whatever the base is, if you do -b to the x, that of course is going to be a vertical reflection across the x-axis of b to the x. The y-intercept changes from 0, 1 to 0, -1. So the y-intercept is 0, -1. The domain remains the same. So the domain is all real numbers, but the range changes. And if you take a look at the graph, you can likely see that this is happening. So the domain remains the same. It remains all real numbers because every x value has a y value, but the range is going to change because, well, if you draw a horizontal line to ask yourself, is this y value in the range? It's in the range of 2 to the x, but not -2 to the x. So while the range for the original graph is all the positive numbers, the range for the reflection across the x-axis is all negative numbers. So the range is 0, whenever you put in interval notation, you always put the smaller number first, so -∞, 0. And again, this is just another way of saying all of the negative numbers, which should make some sense also because, well, what are we doing? We're taking all of the y values and putting a negative in front of it. So that makes sense that the range would be, instead of all positive numbers, all negative numbers. And lastly, I'll just note that the y-intercept, or excuse me, not the y-intercept, the horizontal asymptote remains the same here. So the horizontal asymptote is y equals 0. And that's simply because as the x values get really negative, the y values get really, really close to 0 still. Now, how about for the other reflection, 2 to the minus x? Well, the first thing that I think I'd like to note about 2 to the minus x is I'd like to remind you that this is the same thing, and I suppose maybe I should put b here because all of the things that I'm about to say are true for any base. So let me put b here instead of 2. B to the minus x, that is the same thing as 1 over b to the x. And a lot of the properties of the reflection about the y-axis of the graph remain the same. So the y-intercept is the same, the domain is the same, the range is the same, and the horizontal asymptote is the same. So the y-intercept is going to be 0, 1. The domain is minus infinity, infinity. The range is 0, infinity. And the horizontal asymptote, which I'll just abbreviate as HA, is y equals 0. So while certainly the graph's shape changes due to the reflection about the y-axis, a lot of the important properties of the graph stay the same: the y-intercept, domain, range, and the horizontal asymptote.